In this video, let us look into finding if a rational number will have a terminating decimal expansion or a non-terminating repeating decimal expansion without performing long division. So how do we do that? Let us look into this with a quick example. Say we've got 17 divided by 8. Right? Now this is a rational number. Right? Anything that can be expressed as a ratio of a by b, say 17 by 8 is a rational number. Now, they are of course co-primes. So now, how do you find whether this ratio has a terminating decimal expansion or a non-terminating repeating decimal expansion? So just check if the denominator is of the form 2 to the power m multiplied by 5 to the power n, where m and n are non-negative integers. Now, if the denominator, that is 8, turns out to be of the form 2 to the power m into 5 to the power n, then m and m and n are non-negative integers, then 17 by 8 has a terminating decimal expansion. And you can also find out after how many decimal places does it terminate. So let us see 8. Now 8 is nothing but 2 into 2 into 2, right? So where is the 5? But yeah, you can write 5 to the power of 0, because 5 to the power of 0 or anything to the power of 0 is 1, right? So therefore 8 can be written as 2 cubed into 5 to the power 0, where m and n are non-negative integers. And therefore, since it is of the form 17 by 8 is a terminating decimal expansion. And after how many places does it terminate? That is nothing but just find m plus n. Here it is 3. So this terminates. So therefore, 17 by 8 is a terminating decimal expansion, and it terminates after m plus n, that is after 3 places. In this case, m plus n is 3. 3 plus 0 is 3, right? So it terminates after 3 places. This is just in the brackets to show what is 3. 3 is m plus n. So this is how you find if a rational number has a terminating decimal expansion or it has a non-terminating decimal expansion, repeating decimal expansion, without actually performing long division. That's the important part. So if you do not get it in the form of 2m into 5n, this rational number does not have a terminating decimal expansion. So before I end this video, let me quickly give you an example of a rational number that does not terminate, that has a non-terminating repeating decimal expansion, all right, without performing a long division. So let us quickly do that example as well. So now consider the rational number 64 by 455. Now what we have to worry about is the denominator. So let us see the factors of the denominator. So we will have, it definitely should go in 5. So 5, 9 times is 45, 1 times is 5. This should go in 7, 7, 13 times is 91, and 13 goes once. So now this can be written as 64 divided by 455. This is nothing but it is equal to 64 divided by 455 can be written as 5 times 7 times 13, which is not of the form 2m times 5n. Definitely, right? It doesn't even have a 2. Plus it's got 7 and 13 and all those things which cannot be, written in terms of 2 and 5. So definitely 64 by 455, it is non-terminating repeating decimal expansion. So in this video, we've solved an example of rational number, whether, checking a rational number, if it has got a terminating decimal expansion or a non-terminating repeating decimal expansion. So we've seen that. All you have to do is just see if the denominator of the given rational number is of the form 2m times 5n. If it is, then it is a terminating decimal. If it is not, it is a non-terminating repeating decimal expansion. So this ends this video.